All right. So, welcome to the whatever the word is for every other month meeting of the Mathlib community. Good to see you. Unfortunately, you can't see me. This is the hazards of trying to live on the bleeding edge with iOS 27, I guess. I don't really have much of an agenda for things to talk about. So I'm happy to hear about anything that's really piqued someone's interest over the past couple months, either in or around Mathlib, or any questions people have about life, but contained more so towards Mathlib life. Here mentions the Jacobian challenge, and we have the challenge's author available for us, or at least one of the two challenges, the single author of both challenge versions of the challenge here with Kevin.
Yeah.
Do you want to say?
Which
Do you
one
want to
got
say?
solved? I thought my one got solved, right?
Well, oh wait, you didn't write the algebraic geometry one. Who wrote the algebraic geometry one?
Christian Merton, who's also
Oh,
here.
I think he's also here too. All right.
There he is.
So one of you can claim victory over the other, I guess, or this. Your microphone's off, Christian.
Yeah, Christian's was a day after mine, so I see. So his has held out longer.
As far as we know.
So somebody did it. Is that right?
Yeah, yeah. I mean, all indications are yes. It passed the lean eval.
But do we have a definition of Jacobian that's suitable for Mathlib?
Oh well, that's a different story. So, do you want to maybe do a 5-minute recap about the purpose, and the structure of the challenge?
I can certainly do that. So I have a bunch of postdocs which are trying to formalize statements of annals papers, annals of mathematics papers, and there's a massive problem with this project in the sense that what makes it hard is that a lot of annals statements are statements about Heegard Fleur homology or automorphic representations or Chern classes or random things that we don't have in Mathlib at all. So you can't even state them. So they've been getting a long list of definitions which we can't state. And somehow the definition at the top was abelian variety, and I was going to make that as a challenge, but then somehow I think we can do abelian varieties now. And then the next thing was Jacobians. And so I wrote down a list of properties we needed from the Jacobian of a compact Riemann surface and made a challenge about 2 months ago. And I was quite pleased that no one had done it, because it was just at the time when everyone was saying, oh, AI is doing all this, lean AI can do everything. I was like, well, here's something that mathematicians knew 200 years ago, do that. And then no one could do it. Like no one could make Jacobians and prove it had these basic properties that I claimed were all known 200 years ago, even though that was probably a lie, but I didn't get into the details. I mean, the theorems' names were attached to people who were 200 years ago. So it sort of looked like they were proved 200 years ago, even if that wasn't exactly the case. And then I was rather disappointed yesterday. I haven't looked at the code yet, but apparently someone has managed to solve it. So AI has got Jacobian. So now that's great. So we've got 1,000 more, and so maybe I could make 1,000 more challenges. I don't know, but yeah, but it's kind of interesting to see that AI can make a complex mathematical object and then prove things about it. So I think that that's evidence that whatever their definition of Jacobian is, that you can prove theorems about it, and therefore it might be a candidate for Mathlib. But I don't know if other people will have different conclusions. And I haven't looked at the definition yet. I'll look at it now.
Christian, you want to add anything about your version?
I mean, mine didn't get solved yet, so I guess mine was harder. But I guess Kevin is right. I was 1 day later, so maybe. My impression is that really what changed everything is Claude Fable, and I would guess that if you just let Claude Fable run on the algebraic geometry version with a very minimal setup, then you can also do the algebraic geometry version very quickly.
Can you do Fermat's last theorem with Claude Fable?
Claude Fable ripped through our prototype project in a day.
What was your prototype project? Sorry.
Our prototype homology project.
Oh, Proetal. Sorry, I misheard. What's it done? What do we know about Proetal cohomology?
Sorry?
What do we know about Proetal cohomology that we didn't know last week?
We now know that prototype cohomology actually computes étale cohomology. I mean, prototype cohomology computes elliptic cohomology. If you define elliptic cohomology in the 667 style as an inverse limit of étale cohomology groups, then you have to show that if you do this with prototype cohomology, then that actually gives you the right result.
And it has lean code that does this.
And it has lean code that does this. I mean, this is a sort of easy case because I would claim that I sort of know what I'm doing. So, of course, the things were already set up in a way so that it had a head start. But,
is it remotely Mathlib ready quality, or is it just crap?
No, it's okay. It's quite okay.
Can I qualify the question Kevin just asked? So, one, how much scaffolding did you have in the project to start with? Like, did you have all the main definitions that you felt were the correct ones, and you just needed, people to fill in proofs or machines to fill in proofs? Or was it, here are some things we kind of know what the specification should look like, and the theorems we need to prove, and the machine filled those in too?
Yeah, all the definitions were there.
Okay.
Or most of the definitions were there. And it's also clear that in the commutative algebra part, where we definitely had all the definitions and all the strategy set up, Claude Fable just immediately closed that in one 5-hour session, which was one prompt of the form, fill all sorries to make this declaration sorry free. And Claude Fable just worked for 5 hours straight, which has never happened to me with any of the earlier LLM models.
And would you, on a scale of 1 to 10, what would you say the quality of the proofs look like?
What's 10? Is 10 Mathlib with in the way the FRO would like to have Mathlib look like, so with 0 set option backward defect transparency?
Yeah, in the idealized version of Christian's world, 10 is what you value for code to possess.
I would say it's a 7, maybe.
Okay. And where would you put Mathlib on that scale?
Okay, I think in my estimate of 7, I somehow put Mathlib at 10.
Okay.
Which is not my ideal idea, but.
And would you say previous code was produced by either GPT or Opus 4.8 or Gemini or anything? Where would you put that?
My feeling is that the code quality did not improve significantly.
Yeah.
What improved is the mathematical reasoning.
Okay.
So what happened is that many places in our blueprint that had detailed proofs, where Zhedong and I spent quite a bit of time on trying to figure out an optimized proof. Claude Fable just decided, oh, there's a more direct and faster and more elegant proof. Let me just do that instead of that crappy human-written blueprint proof. And this has
Interesting.
never happened with Opus, or very rarely with Opus.
Wow.
Yeah, I had a one shot some closedness of an incidence variety for sections of a line bundle. And the code was, I would say, even worse quality for the proofs. Like you had 100, 200, 300, 400 line proofs of theorems, but it did it in the end, which was not something I could say for other models.
Did you try asking it to simplify afterwards?
I don't have enough I don't have enough, whatever, however they measure your subscription amount to do that. I'm at 99.99% right now, and I'm reserving, like I tell it, answer very, very succinctly. Don't use any tokens if I have to ask it a question about life. So Lou has two questions. One is related to Claude, so maybe we'll take that first. And the other one we could talk about, which is the Formal Frontier project from the Mathlib initiative. Has anyone tried installing it in a maybe more natural language mathematical workflow, like this co-math petition you've seen out of DeepMind, or other versions of it that appeared in the first proof project, were academic or more organic versions? I will preface this discussion with, I'm 100% convinced that that will be where it will be most impressive of all the things I've seen it do. But what do other people think from their experience or what they've seen or heard about the model?
I think everyone's using Lean 4 skills, but you're talking about the AI co-mathematician.
I mean, you can. There's mention of Lean 4 skills, so that you see. There's always this question of how much value is provided by exposing certain tooling to the model, right? And the model just run lake build and then grep through the result, and that's sufficient for it. Or exposing a version of the language server and having it get feedback from the language server directly. Is that more like? And I don't know if that's 100% settled, and it may depend on the models. And I don't really know from looking at the logs what exactly Fable did when I was working with it.
My impression is that, so the experiment I ran on the prototype project with Claude Fable was without Lean 4 skills, without MCP. This was just plain Claude code. This was out of the box Claude code with no configuration. But everything I did before that with Opus, I usually used some sort of MCP or Lean 4 skills, and I had the impression that it improved it. But
one thing that we probably should do is mention and congratulate the person and the team, I guess, that did finish the Jacobian Challenge. So it is Rado Kirov, who has a nice README where he tracks the amount of usage and also gives an outline of the plan. And you can understand the plan if you have some background in algebraic geometry. Certainly a very very sound plan. And then there was collaboration with B. Sanchez. I'm sorry, I don't know what B is, so I won't speculate. And then GitHub usernames, Tangent Storm, and then I know Mike Douglas too. So it was really nice to see. One, I think that, well, in my opinion, this is the hardest AI formalization challenge that's been put forth and solved up to this point. You always see announcements from, individuals or entities claiming like, oh, we formalized X, Y, or Z, and the conditions of the formalization are kind of dubious, like what they relied on, what they're assuming, what they actually formalized, did it match the reality of the mathematics. But here, you have one of the hardest challenges, if not the hardest challenge we've seen so far, solved by a collaboration of people out there just playing around with the tooling that's available if you pay a decent amount of money for it, but something that, is not, I would say, gated off or restricted to an exclusive group in some way. But I guess, I'd like to congratulate Rado and everyone else involved in that and look forward to see what else comes out of that. It was also nice to see that he was committed to cleaning up and making the code easier to understand. Good. The drive-by, dump of lean code we often see in these situations is not productive if you want to be measured in your take about. We have some more takes on using MCP. Yes, I think my experience in life is that lean is the #1 performance bottleneck for doing these things. And so the more things you can make static checks in your system, the better your life will be, so that the models don't have to go and try and re-elaborate, rebuild lean files.
What's MCP?
Model context protocol. It's a way to expose certain functionality in a declared schematic way to models.
How do I switch it on?
Well, you got to figure out, one, you have to build an MCP. Let's say I want to use something like Macaulay 2. And I want to teach the model how to use Macaulay 2. Well, for Claude Fable, I've been told by multiple people now that it's very good at like PARI GP usage. So it just kind of knows this stuff already. But for, say, a model like, I don't know, Grok or something, you want to be able to be very clear about what the tools are and what they're used for, so the context stays limited when it's trying to use them. And so you write a server that kind of re-exposes all the tools or limited tools like factor this polynomial or find roots or something. And then you have some description of these in addition when you document the different methods that you hit on the server. And so the server intermediates between the model and the code base itself, so that you don't have to make the model learn the jagged edges of some weird code bases. The model just learns, here's the format that I look for. Oh, it has these particular features. If I want to do this, I use this one, I do this, and it just hits that server, and the server interacts with the backend tool. So David gave explicit instructions in Claude to install the LSP. I would say right now the canonical LSP package we have floating out in the ether. And we have a link from Brian as to the GitHub. Yeah. And you can also just tell Claude to go do things, and it will do it.
As long as you know these things are there. Right?
Yeah. Claude will not weed my lawn, unfortunately, but who knows?
Maybe it's worth emphasizing the reason the MCP matters so much for Lean is because it's like the difference between using Lean with VS Code, where you have a live Lean server that has saved its state so far, versus having to launch a new Lean process every time. Like these tools can learn command lines, but the point is the Lean command line, unless you learn how to use the Lean server, which is much more complicated, you're always going to have to pay the cost of starting up Lean and rebuilding everything at the top of the file before you hit the check at the bottom or something. And having any form of running server the agent can connect to saves all that time. And the easiest way to teach agents how to run servers is this MCP server thing. because then you just launch the server for it and you tell it how to talk to the server you've already launched. But you could imagine an alternate universe where you just supply a folder full of scripts that connect to some server that exists somewhere, and that would be fine too.
That's an excellent point, Eric. Thank you.
Is the Lean LSP MCP actively maintained? And is it something that the Mathlib initiative or Lean FRO should consider supporting more officially?
I know people in the FRO are just like, let it use Lake Build and it's good enough. So I think you have to first convince them of the utility. I tend to agree with your assessment about not trying to rebuild Lean or rebuild it as little as possible for whatever tasks you have. Last commit was 3 days ago for the linked GitHub repository, so I would call that pretty active. And from looking at people in the community, I think it has a large amount of uptake. There's maybe 1-2 from Numina. That was a fork of this that adds some stuff. And I haven't checked on its maintenance tasks, but I would assume that would be pretty well active, pretty well maintained. All it does seem like MCP is here to stay now. Who knows?
One reason I ask is one of the risks in having like just one Lean LSP MCP tools that everyone's installing is that if it hits services like Google and Lean Search, then like everyone is overloading those services. And actually, if the FRO were making this tool, presumably they would make it launch a local Google instance. And
Yes.
But at the moment, it sounds like the FRO has money to burn on scaling up their Google servers, so it doesn't matter.
Oh, really? That's great.
There was a post, I think, this morning in response to Google being persistently down of, we'll just throw more servers at it and think about this problem later.
Well, it's like this argument that urban planners always make about traffic, is that the more roads you build, the more it'll just fill up. I think we haven't hit,
The Jevons paradox.
I'm very bad with names. So a little bit of background. Jevons paradox. Okay. Yes, I don't know what this is.
Oh, just what you said. As long as you make more capacity of something, people will fill up that capacity and even more.
Yes.
But it buys you time to come up with a better solution, even if
Yeah.
it makes the problem worse as you wait.
No, it'd be awesome if it was just a default local Google in there. Because I from using these, I know that the models are stupid enough not to listen to the instructions about not hitting these public servers within, X number of heartbeats. So another question we had was about the Formal Frontier Initiative. And unfortunately, I think I'm the person most able to answer this question, who's available at this particular time now. Also, I am not trained on the official languages, so let me take a quick look about what's being said. Okay, so as we've seen and have we talked about so far, the advancement of large language models, machine learning in general, is definitely impacting how formalization is done in both good and bad ways. And a lot of the bad ways, I think, are incentivized through the entities, or caused by the incentive systems of the entities, corporations that are pursuing this particular direction. And so, what we'd really like is to have a more homegrown, organic, and community-directed way to pursue auto-formalization, especially of valuable, keystone mathematical textbooks that would be available to the community, and something that is of sufficient quality to build upon, right? So we've done auto formalization kind of as a one shot, do this, one shot, do that. But one big question is, can you build and chain these over and over and make the body of mathematics we see out in the research academic world right now? And I think that's still an open question. And so making things open and available, sharing the tooling that comes out of this so that people with resources, maybe grant resources or personal resources, can run those tools themselves and contribute or explore, so that the knowledge that's obtained is not just stored away and commoditized, is what this initiative is for. I'm gonna go to the bottom of the chart. Hopefully that's a helpful description. I think what you've already seen so far is, well, there was an announcement about the formalization of the recent counterexample to the sum product conjecture, the growth of these two sets relative to each other. And the fact that that could be formalized is probably not super surprising at this point. But the more important thing from that was, one, it was done in a way without, that was more amenable to building upon, right? So if I just say axiom, blah, 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 and then prove based on the axioms, it's not as easy as proving a conditional statement, right? Maybe you could put a sorry in there and then hope people fill it in. But with a conditional statement, someone comes around and satisfies the conditional, and then you have a full proof. That's one aspect of it, trying to make it more community friendly, more reusable. And the other aspect is just to be more transparent about what exactly went into the process. Like, corporations that do auto formalization, they have, for good and for bad reasons, desire to keep a lot of this information to themselves. Sometimes it's a smoke screen to make things seem more impressive. Sometimes it's just exposure that they don't want to invite because they don't want to share the details and possibly open themselves up, exposing their own IP or other stuff. And so here, accompanying this formalization was a schema that can be used for any formalization project, but it's particularly useful for auto formalization. Formalization.yaml, which it mandates reporting of basic stuff like, what exactly are you formalizing? What's the source, right? Are there previous bodies of work on this? Taking Christian's example, did you just from scratch formalize the relationship between Natal and Pro-Natal cohomology, or did you build off of someone's existing body of work who really needs credit and citation and all the attention in addition for creating the environment where this is possible? And then what exactly did you use as a system? It's not just some black box stored away in the basement of some company. It's like, okay, here's how much of Claude Code I used, or here's my orchestration system that I hand rolled that's built out of these particular pieces. And here's how much relative cost I would expect. Here's how much time it took in terms of wall clock. All these things that it's very hard to pull out of announcements about auto formalization projects in particular, and just be put in one particular place, look through, and then use to help guide your understanding of the project itself. So having more transparent, having clearer community standards for when these things arise, that's, I think, a very important component to this Formal Frontiers project. I'm done talking about that. Any comments or questions from anyone? Well, that's good. It was helpful. All right. So any other things that have occurred in the community over the past 2 months that people want to highlight?
We got funding from Google for a workshop.
Oh, cool.
I haven't advertised yet, but it's going to be 7th to 11th of September. Yeah, and I should probably post that before I go on holiday next week. Yeah, so if anyone wants to come to London 7th to 11th of September to make some formal conjectures, then they should apply to my workshop, which they can't apply to yet because I didn't advertise it.
Lippo has a question.
Yeah.
Sorry?
Well, it is a question. Well, rather than a question is an observation that unfortunately Lean for the Curious Mathematician is September 7th to 11th as well.
Oh, perfect. Because we haven't advertised it yet, and it doesn't have to be 7th to 11th.
Okay, great. Because, and by the way, you officially, Kevin, you are among the scientific organizers or something. It's the thing we are running in Italy.
Okay, perfect.
So if by any chance it can be another week.
Yeah,
the week before, the week after.
Perfect, thank you.
Okay, thank you.
All right, we're actively solving problems. This is good. And so the event that was formally on that week will be.
It's a link for the Curious Mathematician. Yeah, I need to leave 7-11. But I think registrations are already closed. We posted online many times, so I think we had some registrations and many people are coming. And I see here Christian, who will be one of the last speakers, by the way.
And is it purely in person? Is it hybrid? Undecided.
I think Ricardo.
Okay.
I think he was aligned. Do you have any idea, Ricardo, whether it would be recorded or something? I don't know. I think we haven't decided yet.
I don't know, but I think it will be mostly in person.
Okay.
When we can
Yes,
record
but
the talks,
we-
maybe, but
Yes, exactly.
Okay. Yeah, that's good. All right, I'm looking forward to that. And then, Kevin, your workshop is about formal conjectures.
Yeah, it's a Google, right, formal conjectures, the Google repo.
Okay.
Apparently they want more conjectures. So why not put a bunch of people in a room and see how many conjectures they can make? Yeah, at some unspecified time in September.
Here highlights Damiano's new lean-aware diffs. Seen them, but I haven't interacted with them. What? I mean, certainly the ideas I understand, but what are people's experience day to day with interacting with the lean-aware diffs?
This is replacing the grep-based diffs of declarations, right?
Yes, that's my understanding. What does it report to you when you're on your PR? Does it tell you, I've seen these declarations have appeared, these declarations have disappeared?
So I haven't seen any PRs with the new behavior, but I can say the old behavior was frustrating because you would add two theorems with totally different namespaces, and
Yes.
this declaration diff would not pick up that they're actually entirely unrelated theorems.
Yeah, I think at the moment it's just diffing names, the lean aware diff. So namespace aware
Okay.
declaration diff, but not yet type differences.
Okay, cool. Scott mentions a particular PR where got a discrepancy where two additive generated something.
Could someone maybe link an example of a PR where this new tool is running?
Yes, that'd be, yes.
Is this new tool definitely merged in master, or does like okay? His message suggests that it's
Any recent
got
PR?
it,
Do we
but
have
not
it?
necessarily if it was okay, recent, yeah.
Do we have an exemplar PR though? Is there someone? Scott, maybe you can post the PR number for the one he was mentioning if it's of his head. Anywhere else would be good. In the meantime, here also mentions the click suggestions command from Jovan was demoed at Lean Together. Now, this one I don't remember. I'm going to need a little bit of help about what it does, and how to use it.
So I know the tiniest bit about what it does just because I had to look at implementing it. It's some evolved version of the RW question mark tactic where you can select stuff in hypotheses or in the goal, and it will suggest interactively rewrites and other stuff you can apply to the parts of the state that you selected, and then you can just kind of click on what's in the info view to perform the rewrite. It's quite nice.
Okay. I think we have a exemplar PR with the diffing. Oh, and two of them, in fact. I think. And then here's the PR that merged the click suggestions type. It's always great to see quality of life improvements for people using the system like that.
How do we expose the features of these interactive tactics to MCP servers?
That's a good question.
Do they need them?
Yeah, that's also a good question. I mean, you could just have the MCP be able to see all the sub-expert infos at any given point in time, just request one and send the requests back. But whether MCP server actually does that already or not is...
One more thing that came to mind that was launched relatively recently is this phrasebook project. I wonder if anyone here has contributed to that, share their experience.
I wrote something, but it was closed. I wrote the wrong thing. I wrote how to use elliptic curves, but I was told it was the wrong kind of tutorial.
So through that learning experience, you want to describe what the project is? And
oh, well, I mean, there's two things, right? There's the making documentation, which is clearly the part of the thing I didn't understand very well. And then there's the writing stuff in Blueprint Verso, which I do understand quite well, but only because I've been using Claude to write Blueprint Verso for Fermat's last theorem. So Blueprint Verso is this way of, Blueprint Verso is this new way of writing documentation. Verso. It's not Blueprint. I mean, it's Verso.
Is Blueprint Verso using the old Blueprint software, or is the old Blueprint software?
No, Blueprint Verso is a new way of doing blueprints. But Verso is the thing that we're talking about. So you can write lean documentation in Verso, and then you write the lean code you write actually gets compiled and run, and you can hover over it, and it's kind of dynamic and great. And it's very easy to learn, especially if you just point your language model at the Verso, the GitHub page, and say, just do this. This is how I've been writing lean blueprints. I get the language model to do all the syntax and stuff, and then I look at its abysmal prose and rewrite all the prose, but somehow all of the fiddly bits that I don't like doing very much.
How much do you have to prepare or annotate your files to get this to go?
Oh, I've been giving it for FLT. I've just been giving it. I gave some FLT lectures January to April, and I've just been giving the lectures to Claude and saying, write me Verso, and it's very good at doing that. And and it looks nice.
But so it writes you Verso.
Yeah.
The natural language is stored in the lean document. Is it stored elsewhere?
I mean, it writes Verso blueprints. So your original question was about this documentation. All I'm saying, it's a similar sort of thing. You can write documentation using Verso, or you can write documentation that isn't in Verso and then tell the language model to Verso it up.
Okay, I see.
So this is you don't have to really learn Verso in order to contribute to the documentation project.
And now,
you do have to understand what kind of documentation Anna wants, and that was the bit I failed at.
So you now also Versoifying your lecture slides with Claude?
Yeah, I'm doing that.
Using Verso slides?
Oh, not Verso. Oh, no. I'm taking the lectures I gave, and I'm turning them into a blueprint.
Yeah.
That's what I'm currently doing. But I'm sure you could do anything.
So I haven't contributed to it, but I shared a project with the Mathlib people, and they seemed very interested in contributing, because something that we struggle with is that since Mathlib already covers most of undergraduate math, and it's kind of, a lot of our attendees don't have graduate math background, it's sometimes hard to find them projects they can work on. But I propose this as a great learning project, they can learn to use Mathlib and then document it. And I guess, yeah, I'd be curious to know what are the criteria for a contribution to get accepted, so I can share that with them.
So mine got rejected because it was the wrong kind of documentation, because I hadn't been paying enough attention at Anna's description of what. There are lots, people understand documentation very well, and there's lots of different kinds of documentation. And this, I think it's a great idea, getting people to find a bit of Mathlib and document it. I think it's a fabulous way of learning how to use it. But I suspect that Anna's slides are not available. But is there anything in the README? Just be careful to read the README. Where is this thing? Have we got a link to the? We haven't yet. Where is this Mathlib documentation thing?
But Kevin, do you now understand why your piece of documentation was not suitable?
No, because I'm going away on Sunday and I've got a million things to do. But I'm sure I could understand it if I tried.
Okay, I think we're a race, and Eric won. Oh, he found the Zulip chat. The announcement.
It was a cooperative race.
So we've currently got 4. So these will presumably have been 4 distinct PRs. This contents have got 4 things. And the thing that we should read.
To summarize in one sentence, I think is, how do I say blah, blah, blah using Mathlib? Questions of the form. How do you express I would
Then it's
guess
still
common natural language mathematics in, the syntax in Lean using Mathlib idioms.
Then it's still not necessarily clear why how to write an elliptic curve in Mathlib isn't a question of that form, right?
Yeah, I don't quite understand why my style was wrong, but I'm completely fine if they don't want it. It's just that I've got a million. Yeah, I wrote this when we were in Portugal. Anna gave a tutorial, said, let's all write something, let's all have a go. And I had a go, and apparently I didn't do very well. But there you go. But you can see my effort here. There, and you can see, so now you can see how to write an elliptic curve in Mathlib. I mean, if somebody wants to take this PR over and change it to the thing that Anna wants, I'm going away. I've got 3 weeks of travel coming up, and then I'm running a workshop for the next month. So I certainly won't be. This is why I closed it. I certainly won't be doing any more on writing tutorials for elliptic curves. I'm running a workshop in a month, and I'm leaving the country in 2 days' time. So I'm just busy. But yeah, if anybody wants to know how to do elliptic curves in Mathlib, then that's my attempt to explain. And I'm sure it'd be even better if we actually got it into the phrase book somehow.
Do we have an abstract elliptic curve yet?
Oh, we've got y squared equals a cubic.
Yes. Well, one of my colleagues who was an algebraic geometer was complaining about whenever a number theorist wants to write a cubic, they say, well, you could write it in normalized form, et cetera, et cetera.
Yeah. No, but I mean, I know how to do it. I know how to find elliptic curves over schemes, and by an evil hack. Like an elliptic curve over a scheme is a equivalence. Oh, great. Equivalence class of, cover the scheme by affine schemes, and then do y squared equals a cubic on each of the affine pieces, include them together.
Oh,
That's my definition of elliptic curve over a scheme.
okay.
Sophie Morel was horrified by that proposal.
Yes. Yeah.
It would work.
We can say abelian scheme of relative dimension 1, right?
Oh, there we go.
Yeah, so I like that.
Okay, great.
And that's a method that's maybe combine 5 type classes of Mathlib.
And then we need Grothendieck, Riemann, Rock or something to prove that it's y squared is a cubic.
Can you do torsor over abelian scheme? Torsor over an abelian scheme.
We don't know, we can't say, so torsor for which topology? Or we can say torsor in a general, or we can say module object in a symmetric monoidal category.
Yeah.
But we currently can't say it trivializes over some cover.
Yeah.
I actually thought about this, but I was thinking if we can make a general definition in the symmetric monoidal category where you have some broken topology. Can you say what a torsor is? And you can probably do that, but I have no idea what the correct statement even is in that generality.
Yeah, I think it's pretty clear that we're creeping closer and closer to the working mathematician in a lot of ways. And so it's great to see things like the phrase book. And there was another one. There was this project, I think Jack McCarthy mentioned, about annotating Mathlib with Wikidata markers to try and sync up, precise real world statements with their Mathlib counterparts. So it makes it easier for people to just click on a particular link and say, oh, I know about this thing like elliptic curves, what does it look like in Mathlib? And then be horrified that it's Weierstrass form.
That's also Silverman's definition of elliptic curve, and his books are very popular.
Well, I mean, yeah.
It's interesting. It's like two different theories. You know, there's the abelian variety of dimension one side, and there's the smooth plane cubic side, and the questions are somehow completely different. You know, associativity of the group law is somehow trivial for abelian varieties because that's the definition, but it's a tricky theorem for smooth plane cubics. And
I always wondered how much we're going to end up with dichotomy and some linkages between, like, here is an abstract scheme and here is a projective variety cut out by, you know, a homogeneous ideal with with this list of polynomials, the generating set.
Yeah, which
certainly
we still can't really do. I think we'll need quotients of graded rings by graded ideals of graded rings. Do we have that yet?
Say that again.
Do we have quotient of a graded ring by a graded ideal is a graded ring?
I think Antoine has a PR to add that. Some complexities, we have at least 3 ways to write what a quotient of a ring is.
I noticed this recently.
I'm trying to eliminate one of them. So, like, to recap, we have ring quot, which is like, sorry, we have the quotient by an ideal, which is the thing that came first, which wasn't two-sided. Then I think Adam wrote ring quot, or maybe Kim wrote ring quot, which is just inductive type specifically for quotients of non-commutative rings. Then I think I, or maybe Dujian, wrote ring con dot quotient, which is built upon like the add con and con dot quotient that has been around since Zena times. So now we have those 3, and there's this two-sided ideal wrapper around the ring con, which also has a quotient. So we have like 3 or 4 different ring quotient constructions.
Yeah. So that stops you making projective varieties by writing down a collection of homogeneous equations. That's just a dumb obstruction.
I think you just make choices in life and then find out what the consequences are sometime. Maybe we're running up to the hour. I think there's a great question to end with. Ruchara. Hopefully I got that name right. I apologize if I didn't. Is there a project for a first-year PhD student in math? There's worry that a lot of it's already done. So if you're asking yourself this question, where should you go look to find an answer?
Ask them the Zulip.
Yeah.
And say what math you're interested in. First-year PhD student is incredibly unspecific.
Yeah, well, I was just thinking of like Berkeley math and you know what is required. So, but yeah, I can just.
Some areas we have everything. Some areas we have nothing. So it's very much an area-specific question.
Thanks.
Trying to convince people to do Cyber-Wit invariants would be awesome. So my cuckoo clock is sounding. It's probably time. Been a great chat, especially since I didn't prepare anything. Appreciate everyone who came and all the interesting thought comments they shared. We'll do this again in 2 more months. I'll see you there, not elsewhere on the Zulip or in real life.
Thank you. And by the way, it's Ruchira.
Ruchira,
Thanks.
thank you very much.
Thank you.
All right. Take care. See you on the other side.